Hey, I'm Brian Fields, amateur radio call sign W9CR, and I'm kind of excited to speak here at the Ham Radio Village. That's the first time I've been invited to do so. I had quite a few different things I'm involved in. I do a lot with Motorola, I do a lot with All Starlink, but one of the main things I've taken over here and really run with has been spectrum planning and repeater coordination. Normally, this is done through kind of very unknown groups in amateur radio. And my hope is exposing what we're doing specifically in Florida, but the hope is it's more general and our methods, our technology can be used hopefully by other states, by other coordination bodies, by other people that want to bring their coordination software or methodology out of the the late 1950s, 1940s kind of way that a lot of hams and a lot of coordination bodies have done things. So that's why I'm really, really thankful that the Ham Radio Village folks reached out to me and got this topic and some initial slides, got some feedback, and hopefully this will be of interest to the general community here. So what I have is I'm calling it spectrum management, and this is a talk based on some of the other talks I've done here in Florida. But my background here is originally from the Midwest, and I ran one of the first wireless ISPs in Northwest Indiana around 2000 timeframe, so that's kind of South Chicago area. My background is in microwave and carrier IP network design. I've always been doing carrier IP networks since the day I got into computers and networking as a business. I've never worked really in kind of that IT environment. Around 2005, I had the opportunity to come down here to Tampa and took a little hiatus from ham radio at that time just to get settled, and got back into it, really started trying to run some repeaters around here, and we had a lot of stuff happening. So it was a lot of fun to kind of rediscover my hobby. I've really been licensed since 1995. I got licensed, I think, when I was 9. So it's a big portion of my life, and I can say a lot of stuff happened in my life because of ham radio. And so I started what we call our Florida Repeater Council Reform Caucus in 2017, 2016 timeframe. There's a lot of stuff going on. I'll touch on that in a little bit, but it's funny how ham radio can happen like that. So my day job, I'm a senior consulting engineer with a major router vendor. So we build a lot of the stuff that your large ISPs use for routing IP packets and so forth. I'm a board member of All Starlink Incorporated, and I'm one of the founding members of All Starlink Inc. Was around right when that started. Unfortunately, kind of the main person there, Jim Dixon, he passed away at the end of 2016, and was kind of instrumental in getting us going as a incorporated nonprofit entity. I'm a former AmperNet Technical Advisory Committee member, so anybody that's been involved in any of the 44net IP space was kind of doing that until some recent developments, and I decided to step back from it. So background into this, and we're looking at, what is coordination, and then a technical basis for it, because we can't just do things the way we used to. And then some of the process that we actually use. So things like how we coordinate repeaters, what we require from people. And the idea is maybe this will give other bodies that are looking at doing this some idea of, we're asking for the minimum stuff, what they need to be doing and how they need to be interacting. And then some of the initiatives that we've been involved in. So let's do a little background on amateur radio repeaters. I know we're probably really familiar with these, but this is the basics here of a ham radio repeater. It's line of sight communications. It enables these hidden users to talk back and forth very well. different bands. You can do 50 megahertz all the way up to 1.2 gigahertz. Obviously, the most popular thing for amateur radio is really 2 meters and 440. Um, and the higher bands, of course, have more pairs available. I think 2 meters has 72 pairs. UHF has considerably more than that, all the way from 442 to 445 megahertz. And that's a basic overview of it. So one thing I want to talk about is, where do we have FCC rules on this? And typically, VHF and UHF, they're local communications, so where you would have band plans and things like that, the FCC really doesn't set too much there like they do for HF. They've carved out a couple areas per 97205B of where you absolutely can't have repeaters in the ham bands. But other than that, they're going to get to this, which is amateurs have to self-regulate. The FCC does not recognize a frequency coordinator. They let that up to the amateurs in the area. And the ARRLs really stayed out of it. They don't even publish the directory anymore. The ARRL repeater directory is actually contracted out to a third party. Now, the ARRL used to go to the repeater consoles, and they would give them, a pretty sizable chunk of money on a yearly basis of, hey, give us what repeaters you have and we'll publish them. Well, they stopped doing that when they contracted out to this other gentleman, and he absolutely will not give any money to the repeater consoles unless they agree to keep what they do secret and not share it with anybody other than him, not publish it. Now, I'm not going to get into the legality of it, but generally, a list of repeaters, a list of anything, it's kind of like the phone book. It's not something you can really copyright. So you can keep it secret, but why? Secrecy, in my opinion, and I think in a lot of people's opinions, breeds corruption. So what do we need for coordination then? And obviously, amateurs do self-regulation. We're a regional entity in this case. Coordination body must be recognized by the users in its area, not just repeater users, general spectrum users too, because we do set the band plan. All we can do as coordinators is suggest operational parameters that will minimize harmful interference. And again, that's minimize and harmful interference. Not all interference is harmful. Hearing somebody out in the distance when your local repeater isn't keyed up and you're running in carrier squelch is not necessarily harmful, because when your local repeater keys up, you'll hear your local repeater. Looking at like the traditional process, it's kind of 1940s technology, really around the birth of two-way radio. And it doesn't make very good use of the spectrum because it's just based on distance and height. And I say it's the ultimate in ham radio gatekeeping. It really is. And FASMA's really striving to change that. So all our repeaters are modeled and interference is predicted. So as soon as you give us the information, we have a model built for it. And we're giving open access to all that data that we use. So we're the successor to what was known as the Florida Repeater Council, Florida Amateur Spectrum Management Association. And God, I won't get into everything, but the FRC suffered from some serious corruption issues. The board wasn't acting in good faith. So, in a lot of things, the members revolted. We had tons of proxies signed. We had a meeting packed. One of the directors went around and counted up everybody in the meeting and waited 40 minutes until we got up to talk, and then called the police in on us because there was a fire code issue with too many people in the room. Then after that, the board members decided, well, they didn't like the idea that the actual members were revolting against them, so they just decided to vote all the members out of the corporation. It's just very, very funny. So we ended up having getting the old board out and elected an interim board back in July 2017. And the responsibilities of the Florida Repeater Council were transferred to FASMA once it was 501c3. So that's one of the big things you want to do in your coordination body is go for that nonprofit status. There's a big benefit to it. And We're committed to openness and records availability. Everything we have is online. That's a big thing. Our email system, for example, manages all interactions, so we can see a total history of communication. It's basically like a ticketing system, if you're familiar with that. And this is a big point, is we're committed to treating all people with respect and fairness. I can't stress that enough. You have to treat everybody in this that comes to you equally. Coordination's got to be done by a number of people. We actually have a coordination committee that's impartial from the board. And right now we have a couple people, myself and someone else, doing this. And we have 3 other people that are just general spectrum monitors. We have a few other people we call on from time to time, but that's the kind of core of it. And what the coordination job is all users, not just repeater users, but all users. But we're going to focus mainly on fixed repeater stations, because that is the majority of the issues that we come into, as repeaters can't very easily move around the band. And we also maintain the band plan. There's a link to it right there for VHF and UHF in Florida. So when we start looking at this, we start saying, okay, hey, the commercial guys have been doing this for years, and they're doing it a lot more intelligently than we are. So can we apply what they're doing to amateur radio? And I think the answer is yes, with a few caveats. So let's look at the background here, what they're doing. And in Part 90 radio, commercial radio, it's very important that licensees have reliable coverage. FCC does this, they call station codes. So you have FB, FB2, these are basic repeaters, 32 kilometer radius, and you might have co-channel users in there. Now, what they do is they start designating some things like trunking systems, control channels for that, FB6 or FB8. These are central high coverage sites that have a large protected radius from interference. The other one is MO, mobile users. This is important. These are assumed to be at 2 meters, or 6 feet, 1.83 meters off the ground. And that's important. Remember that, because that's the basis of a lot of the modeling that we're going to do. Planning is based on normal everyday propagation in this. And we don't take into account that, you're going to have skip or, tropoducting or anything like that. That's enhanced. That's not something we can really model day in, day out. And in amateur radio coordination, we don't have a business need. We're seeking to have really the most fun and the least amount of interference. So in this case, ham radio repeater is the same as a FB6, FB8 under Part 90. One of the nice things, though, the FCC has is they have the benefit of assuming high-quality radios are used, meeting Part 90. Not all amateur radio equipment is as good as that. So coordination really is based on these signal levels. And we express these, and this is an important thing to understand, we express these as a decibel microvolt per meter. So you got 2 antennas, they're, a meter apart like this, and say they're a dipole. You're going to have a difference or an amount of voltage hitting that antenna that's going to give you 1 microvolt per meter across that setup. So that's an absolute value. It doesn't take into account anything with receive signal, receive antenna gain or anything like that. It is at best, best thing we can put out there is a total absolute value. And it's really great for doing coordination because you don't have to worry about your receiver. You just know his height, and that signal level is going to be there with a calibrated antenna. You can back that out to what it should be and so forth, but it really allows you to model it out. So here's kind of the problem, though, and this is what some hams, amateurs, use as a repeater. We have all the way over here on the left, we have the wonderful 2 Bofang radios or Chinese radios and a little duplexer. I've seen this sold on eBay. And then on the other side, we do have some of the stuff like the Yaesu Fusion repeaters, which they've put out there very, very cheaply. And I mean, they were, I think, charging $500 at one point for them. I know several clubs that bought multiple of these. And same with the Bridgecom repeaters. So these are kind of what we call the two mobiles in a box. They're fine if you're out in the middle of nowhere on a 100-foot tower on a farm. If you're putting it at a commercial site with 70 other carriers there and a trunk radio system, or maybe up on a mountain in California or out west, these just simply aren't going to cut it. So what I say we should use, and this is important here, is you'll see some of this is these antenna setups. And these antenna setups here, for example, aren't always going to be, the end-all be-all. I'm just showing what works in many cases. Spend your money on your antenna system. You can always upgrade your repeater later on. And especially if you're up on a tower, it might cost you $2,000 to have somebody scale the tower and put up an antenna for you. So you want to go with the best antenna system that you can. And in this case, we have these two here. I have one as I think a UHF, known as a DB420 there on the left, and the right is it's a Telwave product. They make a very good antenna. But both those are commercial grade antennas, and especially for Florida, I know this site personally. Both these have been hit directly by lightning multiple times, and they keep working. So some of the repeaters that are out there, this is a Motorola high-power DMR repeater. Tate makes some wonderful stuff, and I really like the Tate product. It actually speaks SNMP. It's pretty cool. These here are the Quantar repeaters. These are starting to come out on the market now. These are amazing. They were about a $15,000 base station, brand new, and now they're very affordable on the secondary market. And then even these here on the bottom, these are the GE, or they're the Master 3, Master 4, Master 5 base stations are the current things that are out there from, if you're on the GE side of it. These are great, and they're synthesized. So let's define interference. This is an important concept we have to do, is define interference for amateur radio. And harmful interference is what degrades another spectrum user's communications. Not all interference is harmful. And in amateur radio, we're kind of used to working in the noise. But this isn't really true of repeaters. As I alluded to earlier, ducting and tropo can enhance propagation. We can't really avoid that. So we have to define a normal service area for the repeater. And this is all based on height, ERP, antenna, all comes into play. And so how do we define this for our quote-unquote FB8s? The FCC uses this concept of service contours and then interference contours, and professional engineering. It costs some money to have somebody certify this for you. Research into this has been kind of ongoing empirically since the 1950s. And we have some stuff up on our library there, good compilation of that. EIA-TIA came out with something called TSB88, and it kind of takes all this together, compiles it with a whole bunch of science behind it, and it's a great reference. So in our case here, we have service contours, and this is what's important. Is I think we're pretty much all hams are familiar with what's called the FM capture effect. And in a service contour, you have a given signal strength that'll override any interfering signal in that area if your planning is done right. Using PL tones made this easier in 1970. Still to this day, you have hams that think putting PL on a repeater makes it closed. That's simply not the case. Every radio I've ever bought in my life has had PL in it, and as I said, I've been a ham since 1995, even before that. So we're talking a good amount of time here for amateur radio transceivers to have these functions in them. Now, wideband FM, when I say 16K0F3, that's what's called the emission designator, but that's wideband FM, meaning it's 16 kilohertz wide. You need about 6 to 9 dB for this to work, but the FCC never really took digital into account for this. The TSB88 standard did. And a lot of this is based on TV modeling. So, as you can see here, one of the things we put together was these PL tones. And we have PL tones by region. in the state. But again, this is just a suggestion. There's certainly options. People use different PL tones all the time. We just try to ensure that they're different between co-channel and adjacent channel repeaters. The important thing here is that all repeaters must receive and transmit a tone. If you're not transmitting a tone, if you're only using receive tone on your repeater, your people that are out there mobile will be in carrier squelch, and they'll hear everything else coming in when the band opens up or when the repeater is not keyed up. So TSB88, as I said, is our major rethinking of this service contour kind of model for commercial radio. And what they've done is model each mode that's out there. So FM, Tetra, P25, NXDN, whatever. Model it and taking into account your signal bandwidth, the adjacent signals that are out there, and then receive filters in their radios, and realistically what the radio is able to discern and its selectivity. So they came up with something what's called CPC, or Channel Performance Criteria. And this is a way to define delivered audio quality based on, for example, in this case, SINAD. It's very similar to the telephone system using what's called a MOS, or mean opinion score, if you're familiar with that. So this channel performance criteria says we're trying to give a delivered audio quality of 3.4, which is pretty good quality speech, 20 dB SINAD. It's not 100% perfect, but everybody can hear it and you don't have to repeat. So we model all the interferers based on that number, which is that we want to have a good quality signal all the time. And adjacent users, so this is something that's adjacent to the channel, have to be considered as well, because in several cases the wideband user will actually overlap the other channel, just because of the way that we have some of the 15 kilohertz channels set up in 2 meters. So the first thing we have to do when you're doing TSB88 planning, again, this is the commercial way of doing it, you define your service area that you want to cover. And then you go and you pick where you need to put your sites and what sites you can get and what your signal is going to be in that coverage area. And you break the whole thing up into tiles. You consider each tile and you then run an analysis on it. But once you have that, you identify a frequency and you model interference per tile, and you make certain that you're not going to interfere with somebody and somebody else isn't going to interfere with you. So this is a whole heck of a lot more complex than an FCC contour, but it does give us a lot more data. It's great though if you're doing, police radio system. You want to know that that radio is going to work everywhere in the central business district or something like that, and everywhere in the city, not just where it's close to the repeater. So let's take this and apply it to amateur standards and how we can do that. So amateur radio has this problem of, we're doing, again, repeaters, communications at a local scale. You're going to receive one frequency and simultaneously retransmit on another. That's a split. It's going to be located up high. Again, for Florida, we're looking at 100 to 1,000 feet. There's only a handful of repeaters, anywhere near that high in Florida. Obviously, you get out west, you can be up at 6,000 feet without a problem on a lot of mountains. Repeaters have excellent antennas. They have a high output power. And the other problem, though, is they're not easily to move in frequency because they have to receive and transmit at the same time. So you need high isolation between that. That necessitates big filters. And the other problem some older repeaters are going to have is going to be in crystals. Some of these need custom cut crystals for oscillators and things like that. So it's very hard to change frequency later. The need for coordination now. We obviously need this because if you're going to have two repeaters in the same area or a very close channel, you are going to have interference, and harmful interference at that. So Being it's hard to change frequency, let's say the coordinator's typically only going to look at the output frequency. The likelihood of two people being on the same input channel causing interference at the same time, being you're only 6 feet off the ground in average if you're mobile or something like that, it's fairly small. And the signal is going to take up what's space on the channel known as bandwidth. And it's not always necessarily the same. That's why I point that out there. So we take this and we get an emission designator from it. I won't go through all this, but here's some of the typical codes. And what's nice about it is it gives the bandwidth for 99.5% of the emission. And then, F3, for example, means it's FM. So typical wideband FM is 16K0F3E. And again, channel size. One of the things we're doing right now is moving a lot of the digital stuff that's out there. They need only what's called a narrowband channel. They don't need a full wide channel. They can make a half channel and be just happy there in a lot of cases. So here's what we're using for standard splits and bandwidths in Florida. I won't go through everything because this is going to change. You get out west and repeaters on UHF, for example, they're from what we would say they're upside down. They transmit high and receive low instead of Florida transmits low, receives high. And we are working to define this a little bit better. The previous group didn't really have it worked out. And the important thing, though, to understand is if you're going to use a wideband repeater or wideband mode, it's going to occupy two narrowband channels. So you can't use either one of those if somebody's using wideband there. And this is one of my favorite slides. This is what I say the legacy of bad decisions on 2 meters here. 2 meters has two main channel sizes. Below 146 megahertz, it's 20 kilohertz. Above is 15. Now, this is different in other states. Again, I'm just speaking to what Florida does. The offsets move back and forth, especially as you get above 146 megahertz. Narrowband makes a 10 kilohertz channel from the 20 kilohertz, which is usable for most digital modes. And then your 15 kilohertz channels make 7.5, which isn't useful for almost anything other than NXDN and maybe D-Star. So the other problem we have with 15 kilohertz channels is you can see here, this is the wideband FM being modulated. It actually occupies much more space than 15 kilohertz. And the advantage to this is, well, we can pack things much closer. And because it's wideband FM, it's not always going to be that wide. It's going to be spaced on average. Maybe it's only going to occupy 10 kilohertz, but when somebody's voice peaks or whatever, it's going to go into the adjacent channel. This is the way it's been done. This is the way it's done even on some of the commercial spectrum. So what happens when we put all this together? Well, as you can see here, we have everything overlapped with 3 other ones being modulated fully, and the channels there are in green. So analog is never, very rarely at 100% modulation. Digital, though, is always at 100% modulation. So we obviously can't do this with a digital signal, but an analog signal we can do because it's not always going to be that wide. So this is what's known as adjacent channel power ratio, or ACPR. And as I said, this is a worst case scenario. So what we do is we determine our ratio needed here between the peak power of a channel and the amount. If it's at peak power, what's that mean for the adjacent channel? And in this case, you can see here's our peak, and then you see in red where our adjacent is, and we look at the delta between that. In this case, it's 31.7 dB off. So if this thing's receiving with a very strong signal, that means in the adjacent channel, it's going to be down, what would that be, 10,000 times, almost 30 dB. The cool thing is TSB88 actually provides this information to us for every known modulation, well, except for D-Star. So let's put all this together. And this is going to get on a little bit of math. I won't go into everything, but we want to have a service area. So that's 20 dB SINAD, delivered audio quality of 3.4. So for FM, this means we need to be at least 6 dB over the interference. And we need, say, a negative 110 dBm input signal on a half-wave antenna. We figure all that out to get back to, okay, that's a dBm into a receiver, and that's, decibel microwatts. What's that in microvolts across a meter? And this is how we get back to it. It's 8.33 dBu in this case. So we have 16 dB for noise invariance in amateur radio. That gets us up to 24 dBu. And reliability. This is where we go from 50% to 90%. That's 12 dB at VHF, 14 at UHF. So we add all that together, that gets us 36.33 dBu. The value used by the FCC is 37 for VHF, which aligns really closely with this. I was actually surprised when the math came out that good. Excuse me. So this is the other thing then. Then we have 18 dB between our intended signal and any co-channel interferers. So this means that any co-channel signals are going to be in our service area for our repeater 19 dB or less. That gives us 18 dB absolute worst case scenario. Most of the time it's going to be a lot less than that. Or a lot greater than that. The signals are nowhere going to be that strong inside that service area. We take into adjacent channel power ratio for FM. It's going to be an extra 5 dB, meaning at the overlap area, the adjacent channel must be 42 dBu, but that's going to be on the adjacent frequency so that it doesn't overlap into our area. So our coordination basics here, and we're going to find the best pair for a repeater in a given area. Sometimes there's no pairs open. We use RF signal software to predict a lot of this. This gives us our service contour and gives us that interference contour with all the mathematics that I just discussed. So the important thing there is we're predicting for what's called a 50-50, or 50% of the time at 50% of the locations in an area. That's for the service contour. Interference contour is going to be at a lower value of 50/10, or 50% of the time, 10% of the locations. And optionally, you're going to have that adjacent channel as well. That's really only an issue in 2 meters for us. Again, in some areas, you don't even have that issue because the band plan makes a lot more sense. So we're going to assume that we have a small amount of interference. We don't want to have harmful interference. And we want to make certain that that interference contour from somebody that's co-channel doesn't overlap our new repeater's service contour, and vice versa. That way we can prevent a strong signal co-channel in the same area that our repeater is. So this is why we're using CTCS, DCS. It's a really important thing. I can't stress that enough. That's so important in modern FM radio, and digital has less of an issue with that because you have color codes and so forth. So let's try to visualize a service contour here. I got 2 service contours here. This is in dark red. Say this is a 37 dBu area. Our light red and our light green that comes here is our 19 dBu interference contour. And what we're going to do is make certain that that green service contour, or light green interference contour, doesn't overlap our service contour of dark red. It does a little bit here, but for amateur radio, this would be acceptable. It's only going to be on the very, very edge there. This would work. Obviously, though, probably wouldn't work too well for the green system, but that's the issue. Blue here, you can see that's much smaller because it is a stronger signal, but again, that's 15 kilohertz away. So it's going to be have to be a stronger signal when it's actually, you look at what's on frequency. And users in the red area here, if they're in carrier squelch, if they're in that dark red area and we're running carrier squelch, they would hear that green repeater out there in the distance, possibly. However, once their repeater that they're on, that has that dark red service area, keys up, it's going to capture their receiver, and they're not going to hear anything out there. So that's why if they are running PLD code, they won't hear anything. They won't hear that. And it's not harmful interference. It's interference, but it's not harmful. Here's our standards we use for we call our contour levels across the different frequency bands. I won't go into all these. They do get a little stronger as you go up higher in frequency. So the service contours get a little bit smaller. And what we're actually doing for modeling this, we're using free software. So anybody can take it, look at it. Everything we're doing is based on what's called this irregular terrain model, or Longley writes. And there's a Wikipedia article on it. I won't go into it too much, but you take all this stuff into account, and it gives you a percentage or confidence in each area. Some of the stuff that's out there is Splat, which is free software for Unix. It's open source too. I mean, when I say free software, it's free as in GNU GPL. Signal Server's the same thing. It's based on Splat. It's actually what we use. However, it is multi-threaded, so we're able to model stuff a lot faster, especially when we're doing it on a central server. So FASMA has models built automatically for every coordinated repeater. And all these are based on this SRTM data, or Shuttle Ranging Terrain Mapping program. It's a digital elevation model, so it shows you, if you have mountains, if you have a ridge in the center of the state like we do in Florida. Again, Florida is pretty flat, but we still take that into account. The nice thing is it takes into account the fact that it's at basically the top of the trees. You have high quality data, but we're actually using the 3 arcsecond data, which is about 90 meters. Our terrain doesn't change that much. Again, if you were doing this in another state, somewhere in the mountains, you might have to use the higher quality data, the 1 arcsecond data that's going to have more resolution. North Florida, I have a link in here to that, has some issues with gaps in the SRTM data, which was kind of fun to figure that out and work around that. So here's a modeling example here. And you can see this is 224280, and this is as it pops up, because all this gets outputted, goes right into a CAMZ file. You can load it in Google Earth. And this has our blue 37 dBu service contour in the center, and then the 19 dBu interference contour around it. And you can see obviously the interference contour is a lot larger, but that blue area is going to be your area that you're going to have reliable service in to mobiles and handhelds and things like that. So let's look at a couple other coordination examples here of what we're doing. This is one here. This is about 700 watts ERP. Shows the service contour in red in this case. Interference contour is in yellow. There's no adjacent channel to take into account because it's a 20 kilohertz bandwidth here. And we could actually look at this and say, hey, you know what? A smaller coverage area repeater in maybe Palm Beach code channel would work on this frequency. Same thing here. Here's a coordination example for 2 code channel repeaters, one on one coast, one on the other. And these are actually in operation right now here in Florida. And kind of what's neat is you can kind of see down the middle of the state there is what's called the Mid-Florida Ridge. It's this, I'd say it's a mountain, but it's the tallest area in Florida. I think we even get up to maybe almost 150 feet above sea level. But it does show that the RF is stopping there and not propagating around that, because it is taking into account the elevation model when it measures this, or models this, I should say. So in this case, say there's very little chance of interference. Both these repeaters users, there's a good possibility when the band opens, they're going to hear each other carrier squelch. But that's not so much an issue, because day to day it works perfectly. Here's another one we did. This is an example of showing something that obviously would not work. In this case, there was a very high level user. They had almost 1,000-foot broadcast tower they were on. They wanted to find a 2-meter frequency. And both these sites that we looked at, we said, hey, let's do it here. Will this work? And obviously the repeater there in Tampa in blue, you can see where it's overlapped multiple times by the green interference contour from the proposed repeater there over in Orlando. And obviously didn't work. We had to go find him a different channel. But we're able to prevent that because if you just looked at this based on the old way of doing it, which is distance and height between sites, this would qualify. This would work. But when you look at the actual model, you say, oh, there's no way this is going to work. Or we're going to tick all these people off over there in Tampa. So let's focus on what a coordinator can do and what they can't do, because we're not the FCC. Coordinators should be happy to moderate harmful interference between coordinated repeaters. So obviously you can do that. If you're coordinated, it means you're agreeing to that. Like, let's work together. And obviously somebody has to give. There has to be a little back and forth there. We can't really do anything with our uncoordinated users. And if you ask nicely, see if they can coordinate, maybe they'll resolve it. It's on the trustee to really go to the FCC. FCC says an uncoordinated user causing a coordinated user interference. It's the duty of the uncoordinated user to fix their stuff. All we can do is really provide the coordinated trustee proof that they need to go, to the FCC. We can't really get involved, and it's best to never try and play, King Solomon here between two people. So, as I say, the bottom line here, we only recommend parameters for station operation. Coordination can't function if there's no cooperation between amateurs. That's like, we all have to get along. And I don't know what it is about amateur radio. There's a lot of people, I've been on that frequency for 50 years, or, maybe they haven't been coordinated there, but, well, they've been there. Or they're on, we had one case, somebody had a repeater in a different state on the same frequency and put up a repeater here in Florida without coordinating it. So, well, that's my frequency. I was like, but across the entire United States, that's okay. And then on the other hand, we've had a lot of people that just really want to work with us, and that's cool too. I really like that. So how do you structure a coordination body for success? And that's one of the things I've thought about, because we had a really poor coordination body previously here in Florida. And how do we prevent the problems from before from happening again? And that's why I say structure your body, your coordination organization for success. And as I say, there's many options, but you're fundamentally different than an amateur radio club. You're not just a ham club. You're providing a service to a lot of people with a lot of different goals. So one of the things we did is we committed to openness day one. We had an organization that was very secretive previously. I said, the way to solve that is just put sunlight on it. So we have the listings open on the web. We have documentation for the organization stuff on the web. And possibly provisions for membership if that's a thing that your group wants to do. Structure your board of directors. Have some written job descriptions. Have some expectations from board members. Have an introduction where you go through your state laws for operating a nonprofit. A lot of people aren't familiar with that. There's things you can do in a regular, for-profit entity, or a church organization or something that you absolutely can't do in a actual non-for-profit. And then also ensure there's something in there to prevent the board if you get the wrong people on there and they go nuts. Because when these things are working, most people don't give them too much thought. And sometimes you get a lot of people that are on there that maybe don't have the best goals of the organization, in their mind. So think about that. I don't have any good answers to how to fix that. That's a fundamental problem of government anywhere, really. The important thing, though, is your coordination standards and technical advisors should really be independent from your board. Your board runs the organization, but they can't just go in and tell the coordination team, go coordinate this repeater right now because we're the board and we told you, or something like that. You want to prevent that. So our coordination committee, these are people doing the real heavy lifting. So they go back and forth with coordination. So somebody submits something, we take a look at it. Is it filled out right? So on and so forth. They do everything via email. I try to really limit phone calls here. We use a ticketing system called RT. You can use anything you want. Probably want to use something that's open standards. RT is kind of really the best thing out there that's open source right now. And ensure that they're doing email from their non-personal addresses. I get a lot of the coordinators from other states where we have to do, cross border coordination to Alabama or in Georgia, Mississippi area. With Florida, they're emailing us from personal addresses. That's their business. They can do that. But I think that's really bad for an organization to have their people do that. So we have people that have different skill sets. A lot of people can't do the coordination side, or they don't want to get into it. It's pretty complicated. We have spectrum monitors, so they just get assigned to go verify something, make certain it's there. This is the problem I think all coordinators have. We call them paper repeaters, people that just like to have their name in the book, but not actually put anything up. And that's a real problem in any place, because once somebody's coordinated, it can take, easy 3 to 6 months to decoordinate them. Because you just, even if there's nothing ever put up, you have to go through the process. You can't just, remove them without any due process. And some people are better at doing calls. Some people are better at speaking. Some people are better at doing outreach. So figure out who's going to work best where. And this is the important thing, though. No one to say thanks for the offer of help, but no thanks. There are some people that go around. I call them the sash collectors. They get on the board of everything and they don't really do anything. So watch out for that. But that's not just applicable to a coordination body. That's a lot of things that this can mean and can be applied to. So let's look at really our process here in the last 10 minutes or so of this. What we go through and what we look for people when they coordinate with FASMA. And the idea being, maybe you can look at this and get some ideas from it if you're going to improve your coordination body. Or, hey, maybe you're in Florida and want to get a repeater coordinated. That's fine too. So prepare, have your site, have your permission in order. We get people all the time. Hey, we're going to go put something up here. They don't have a lease. They don't have any of that stuff together. And they want a frequency for something they're never going to be able to get on. The day of getting onto a big tower or onto a building now with a handshake and no insurance and no verification, that's you haven't been able to do that since probably the early to mid 1990s. Everybody is very concerned about insurance, liability. I know there's a lot of people that are just able to get up there with the handshake. Really can't do that anymore. So make certain you have that in order. We have an application form that's a PDF. I would like to have an online form, but I'm probably not the greatest PHP coder. I'm certainly not the greatest coder in any means. So something through email is a lot less to go wrong with that than putting something that's going to interface with the database up there. We go into our ticketing system via email, and then any questions we have, we'll go back out, answer them, and when it's approved and online, you let us know. So, important thing when you're doing a repeater, and this is people that are putting a repeater up, is make certain you have your funding, because none of this stuff is cheap, and especially antennas, they're a consumable item. Know the band, know the mode you're going to go on. You want to make certain if you're doing wideband, it's 20 kilohertz, 15. And again, this is going to vary state to state, but you want to come correct, because the less work that your coordinator has to do for you, the more chance you're going to have of getting coordinated. Especially if you're looking for only a narrow band channel. If you're doing digital, you don't need a wideband channel. So fill out the information there. We actually put a very good website together. Goes through everything step by step. Read the documentation. It's there. It's meant to be read. If there's something you don't understand, you can always reach out to us. This here is a great example of a coordination form that was put together. As you can see, we have a very simple form, asks a bare minimum of questions. And, in this case, everything was correct. And it was a 900 megahertz repeater, so that's almost a Pez dispenser when it comes to getting coordinated. There's not a lot of 900 activity, at least in Florida. In this case, the guy went through, said, hey, here I'm doing a new repeater. The subject was good. Little introduction, attached it, and you'll get an email back from us saying it's been received. This is a standard thing. Anybody that's worked with a ticking system, anybody that has worked with a ticking system is going to know this. As you can see, it comes back from us. It's got the auto reply. Thank you for coordinating it. And then we'll process it back and forth. Now, one of the important things in this is keep the subject line intact, or at least keep that coordination number, whatever, in there, so that we can keep that correspondence together and we have the entire history of your ticket that we can go look at. Reply will typically do that and make it very easy on you. So in this case, we say, hey, please respond to any inquiries promptly. I think the person that was coordinating this, requesting this, they went out of town a little bit, and we followed up a few times and said, hey, what's going on? Haven't heard back from you. And finally got a response back. Okay, here's what we're looking for. We're good to go. And in this case, you see we put it on the website. Came out very easily here. Here's a new repeater. Please let us know when it's in operation after 60 days or before that, as soon as it's on the air. Makes it very, very easy to do. Again, 900 is practically a Pez dispenser when it comes to getting coordinated, at least here in Florida. There's not a lot of activity. I think I have a repeater on 900, and there's quite a few in South Florida, but the majority of the state does not have a lot of 900 activity. There is a lot of noise on 900 too, so that doesn't help things. And please let us know when it's online. In this case, we got this back saying, hey, we granted the coordination. You can see we put a reminder, and this is a good thing. Most ticketing systems will support having a reminder. We have that in the system. And we just followed up, said, hey, is it online? Last time we heard from you, you were coordinated and working to get the thing online. And we did get a reply back from him, and yeah, we're good to go. And again, though, this is trusting the trustees and the people involved to tell the truth. It's just like dealing with the FCC or anybody. We have to assume that most people are telling us, the right things. It's, we're not going to go out there and verify 100% that this is online or that's online. So this is the other part of the thing, is what happens and why do people get rejected, or so on and so forth, and how do you deal with that? I think this is important that coordination bodies, address this, because a lot of stuff is going to get maybe rejected if it's the first time they're doing it, or, not everybody's familiar with this, as there's, a lot of complexity to the process. So about the only thing we reject right off the bat is just incomplete applications. Handwritten or scans of the form, I can't. I think we make it pretty easy, but I've had people fill out the entire form on their computer, take a picture with vertical video of their, vertical picture with their phone, and then email that with all the moire effect and everything of their LCD monitor. And it's just, it's interesting to see how badly people can screw things up when you're like, well, this should be really easy. So that's another thing to learn too, and anybody that's done software development will realize that. And that's probably, again, why I don't have an online form for it, because the amount of filtering I'd have to do on that would be considerable. Ones we suspect to be fraudulent. There are fraudulent forms that are out there. Again, a lot of people like to get their name in the book, get their, hey, I have a repeater coordination. Well, I don't have any repeaters on it, but I have repeater coordinations. And we'll just kick that out, because it's pretty obvious when somebody's trying to do something, and that's kind of the discretion the coordinator has. And I say, even if you're rude, we'll try to help you. there's a lot that can be lost going through email, and things can be taken the wrong way, especially when there is sometimes a language barrier involved. At least here in Florida, we have a lot of people across the state that may not have English, as their first language. So when that happens, we kick it back. It's easy. Just correct it and resubmit it. And we want to continue to work with people. And I think every coordination body should want to work with its, people that are wanting to coordinate repeaters. Because the alternative is they just ignore it, and then you have bigger problems to deal with. So in this case, here's an example of stuff that we'd reject because everything was filled out and was just missing. And this particular individual went and coordinated like 4 or 5 different repeaters at the same time. I think some of these were recoordinations, and there was no information in there. It was just, well, that's great that you get a 100 hertz PL tone and the frequency, but where the hell is it at? And they were all like this. So if it's your first time doing it, just submit one and see what is the problem, if any, with that first form, and then you can learn how to do it rather than making 4 or 5 of the same mistake time and time again. Oh yeah, this was pretty bad. Okay, so we can see the entire thing full here. This was like somebody hand wrote it on there rather than, it's a fillable out PDF kind of a thing. Generally most people don't even have to print it out or anything. So I couldn't read any of this. It was horrible writing. I just was like, you got to be kidding me. So this will get rejected outright just because there's too much ambiguity to it, and it makes us have to work too hard to scratch our head to know what they want to do. In this case, this is one we suspected to be fraudulent. All these came in within the same general time period. They were all exactly within minutes of each other. And they were all for different frequencies, for different, areas, and everything was identical about them. They were using 1/4-inch Superflex, 100 feet of that on every single site, different buildings they were on across the entire county, and they were all identical. I'm like, that's not the way this stuff works. And went back to them. They were evasive. That's what you can do. So we actually put about 3 hours of work into this and figured out that it was kind of BS. Because, when you're asking somebody to do a coordination, it's going to take the coordinator, minimum 30 minutes to an hour, even if everything's in perfect order, more than if they have to go back and forth, which is another good reason to use a ticketing system for coordinators. And as I say, even if you're rude, we'll try to help. I said to this person, like, hey, this is the 5th time you've submitted this form wrong. Can we help you out? And he got. It wasn't my intention to be rude to him in any way. I just said, whatever, and he took it the wrong way. And I'm like, look, I didn't intend it that way. I just wanted to apologize to you. Let's work, and go forward here. This stuff happens sometimes when you go through email. So one of the other things that a good coordination body should do is have a way for people to do initiatives or affect policy or change stuff. Maybe they're not on the board. Maybe they're not even on the coordination committee, but they have an idea. You got to ask people what their ideas are and not just shoot them down. And this is very common in amateur radio is, the person proposing something, well, that's an idiotic thing. Why do you want to deal with that? So you have to be accepting of that. And we have a way so people can come in there and propose something, and we've had some good stuff come out of this. And 2 of these, one of them that's actually policy right now, another one we're just studying. The first one here is what we call our itinerant or our backyard repeater policy. And as you can see, this is for a lot of people, only want to put a hotspot up or a small repeater, 2 mobiles back to back at their house on their tower at 50 feet and walk around the street with their handheld. This is great. People want to do this. Here's our requirements for it. It's going to be on 70 centimeters, low transmit power, no crazy high gain antennas, no higher than 50 feet. You got to run PL, DPL, whatever. And you don't even have to coordinate it. You can let us know and we'll put it in the book. That's fine. Or, put it in our records. But you're not protected from interference. Anybody else can come along at some time and set something up, and, you might have to change frequency. The nice thing is we put everything together so that the frequencies are all very close to each other. So most typical flat pack duplexers, you're able to do a, maybe tune it in the center and you'll get a couple hundred kilohertz on either side. And that's enough if you need to change frequencies without having really any appreciable effect on it. We have some narrowband, we have some wideband channels here. This has been just a huge success in Florida. So next thing we're looking at, and I got to say this is a preliminary study. So 2 meters has had this real history of like just stupid repeater issues. It was the first band that repeaters ever came to back in the 1950s, 1960s, right after we got the band. We never had 2 meters before, I think 1946 or something, 1947. We used to actually be in the AM aircraft band right now. Down on 114 megahertz was our 2.5 meter band. So 146 to 148 in Florida is 15 kilohertz for wideband channels, 7.5 for narrow. Narrow's not too useful for anything, as I've alluded to. And these first repeaters were only allowed 146 to 148. You had to have a tape recorder on it. You had an FCC application for the repeater. It was crazy. And originally we were doing spacing based on 60 kilohertz. Then we went down to 30 and 15, and that's how we're getting to 7.5, because we were using wideband, real wideband FM, 15 kilohertz deviation. And it was, the frequency stability wasn't good. You could, if you were in Part 90 at the time with the FCC, you could be plus or minus 7 kilohertz and you'd still be compliant with Part 90 in the 1950s. It's pretty funny. So hams are limited by the equipment of the day. If you had a mobile in your car, you were looking at something, even in the 1970s, you had a Motorola Micor that was $1,500, and maybe you had a 3 or 4 different channels you could put in it, or you had the expanded 8-channel pack. All those channels had to be within about 500 kilohertz of each other. So you picked either 146 or 147 megahertz, picked a couple channels that you wanted to be on, and that was it. So in 1970, these application requirements was dropped, and a lot more spectrum opened up for repeater use. And it really took off. So the thing we've been studying, though, is trying to get a couple more repeater pairs out of this, perhaps for some itinerant and portable type repeater stuff too. Designate a few of those for that, using a 1.005 megahertz offset. And the reason for this, if you look, our different simplex frequencies that we have in Florida line up very nicely with this. Pretty much every radio that's out there can be programmed for odd splits and everything. Very, very few radios still only have a fixed 600 kilohertz split. We'd of course exclude 146.52, and not all these would be permitted. They're going to be in certain areas. So it's something we're just studying right now. We're always looking for comments, looking for feedback on it, and it's still in that research phase. So that's the end of it. I want to thank you for allowing me to talk to you for the past hour. Hopefully it hasn't been just useless. I know this can get pretty dry. It's something that I think is interesting to see, because we're at the interaction between a lot of amateurs, a lot of people getting into it, a lot of people wanting to put up a repeater. And I want to encourage that, and I think all coordination bodies should really want to encourage that and work for not just their members, but for the community in general. And how to structure yourself to be able to do that is so very important. So I also want to thank the Ham Radio Village people at DEF CON for inviting me to talk and allowing me to give this. Maybe next year I'll have something else that I'm involved in. I can give an update. Maybe that'll actually be in person with all this COVID stuff that's happening. So again, thank you very much. Again, Brian Fields, Brian at FASMA.org if you have any questions. And thank you very much to our DEF CON and Ham Radio Village coordinators here.